On the television show It's Always Sunny in Philadelphia, a character named Dennis Reynolds is upset because of his low date quality rating on a fellow website called Raters.com. According to data, Dennis's rating after 33 ratings, he has a mean of 1.7 stars over the course of 33 ratings. In part one, let's assume that the standard deviation for the data is 0.2. Now, the standard deviation for the data, this is saying that we have 33 ratings of varying levels of stars, where the average comes out to be 1.7. So in other words, if you look at entry number 1, entry number 2, 3, all the way up to 33, there are going to be different values of stars. 2, 1, this person here gave 0, maybe 2 at the end, right? So what is the average of all these values? Well, you add them up and you divide by the total. So that would be x bar, because that's the sample, equals add up all the x's and then divide by the total. And the answer to that is 1.7. You're given that information. Now, something important, very important, just as important as the mean, is the standard deviation, because that tells us how much do the data vary. In other words, is somebody giving him 0 stars and the next person's giving him 5, the next person's giving 0, 5, 1, 5, or is it consistently right around 1 or 2 stars? That's what the standard deviation measures. So here we're given the standard deviation, all right? And in this case, we can think of it as being the sample standard deviation, which if you wanted to calculate that, you'd need access to all 33 ratings. And then you're going to use the formula from back in the day, which is where you're going to figure out how much does each individual observation deviate from the mean. And then you're going to divide it by n minus 1, and then you take the square root of that. We need a little Greek symbol there, representing add sum. So in part one, we're just we're going to pretend that the standard deviation were 0.2. Part two, we're going to pretend the standard deviation were 0.8, and then part three, we're going to pretend the standard deviation were 1.5. And everything else is the same. And then part four, we want to really figure out what is the relationship here. Like, how is the confidence interval affected by this measure of variability? Now, I want to point out the following, that the population standard deviation, in a practical sense, it's not known. So we would calculate the sample standard deviation, because that would come from the sample, all we have access to. Sample here of 33 ratings for Dennis. When we're using the sample standard deviation, we want to use a slightly different normal distribution. It's called the t-distribution. All right, but for our purposes here, we can just assume, because of the central limit theorem, that these are pretty close together. And in fact, they are, no matter what. They're going to be practically the same thing. All right, for our purposes here, for 95% confidence interval, we can just proceed as if we have the value for the sample standard deviation, or we have the value for the population standard deviation. It's all going to take us to the same place, where we're going to use this formula, x bar, sample mean, plus or minus the margin of error. And the way we calculate the margin of error here is, let's just write mo for now, margin of error. The way we calculate the margin of error is right from the empirical rule, the z-score, which I'm just going to put 2 because it's a 95% confidence interval, and from the empirical rule we know that this would be 2 to trap 95%, and then we're going to multiply by the standard error. And we're going to take this value and substitute it in here for the margin of error, and we're going to interpret.